All right, live from beautiful downtown Southern Maryland. It's time again, finally, for Gears of episode number 20, 15th of February 2016. Happy Valentine's Day to everyone. All right, so it's been quite a while. It's been about since we did one of these. The lab's getting reworked, and that's taken not in an easy way to get to them. So whatnot. So anyway, we're back. The lab's not quite finished. We had to today we're going to do a little talk about two of my favorite tools, the Bus Pirate and a Saleae logic analyzer, and we're going to show how you can use those to debug, hack I2C, and some off-board chip. Like in our case, we're going to do the MCP 4725 digital to analog converter. I think that's the number. So we're going to show how that works and how you can use the Bus Pirate and the Saleae logic analyzer to probe that chip. Before we get into that, though, I want to go ahead and thank our sponsor, and I am still trying to figure out these new whiz-bang Google new Hangouts. There we go. So let's go with that one. All right. So big thanks to Audible. You can head over to audibletrial.com/steampoweredpodcast, where you can sign up for a free 30-day trial of Audible. That is good. Basically, that'll give you one free credit. That credit is good for one download of a book. There's currently over 180,000 titles, and I am personally listening to Game of Thrones. I've watched the HBO show and never read the books because I'm a lazy son of a gun who doesn't like reading Dead Tree or even a lot of ebooks. But audiobooks are pretty cool because I can listen to them when I'm going to and from work, commuting anywhere, going on vacation, whatnot, listening last night in the tub with a glass of wine, with my candles going after a long, hard day of working in the wood shop. So, they're good for anything. And like I said, my wife and I, we are card carrying members. We pay for our membership every month, and I think I'm listening to Game of Thrones, and I try to switch it up with some books like Creativity Inc., the Ed Catmull Pixar book. So try to listen to little technology, innovation, business books in between the Game of Thrones. Like I said, there's 180,000 titles, so that means there's probably something out there for everybody. Fiction, nonfiction, sci-fi, romance, mystery, classics, everything. That's it. After your free 30-day trial, it's $15 a month. You get a credit every month. That credit is good for one book to download if you so choose, and you want more, you can buy audiobooks on your own if you don't have a credit waiting. Sometimes they offer you deals where you can get additional credits for a discounted price. So however you like it, however big a audio file you are, there's probably a way to satiate that. Well, it's a big word at Audible. So yeah, we thank Audible for their sponsorship, and again, head over to audibletrial.com/steampoweredpodcast. You can sign up for a 3-day trial, your free 30-day trial from there. That gets you something, that gives me a little something, and I guess Amazon gets like the 2/3, so everyone's happy. Anyway, that's our sponsor, and again, we appreciate them. So let's go. Let's jump into it. No time to waste. Let me X this one out. So before we get into the goodness that is the Bus Pirate, I wanted to talk about a couple of things that I'm kind of excited about that are coming out this year. I think we've talked to some of them on Steam Power Podcasts, but I don't think we did anything over here at Gears. So the first cool thing, I picked one of these up over the holidays, so I guess Santa was good. It's from Occipital. base structure sensor. Basically, you plug this little doohickey onto your iPad or your iPhone, and magically you have a 3D scanner. So you probably heard me before I talked about Skinect, and I think you're the same guys that do Skinect, that uses the Kinect from the Xbox to scan. The problem that I was having was, predominantly I'm a Mac person, and a very powerful, graphic intensive computer would have been a lot of money, because basically my issue was I was having with Skinect is I was getting very low frame rate, even though I had a Core i7 laptop. I don't think I had a very big fancy graphics card in there, and I think the graphics card makes a bigger difference. So I was getting like 3, maybe 6 frames per second on my scans with the Kinect, and it was tethered with a wire. So walking completely around something was a pain in the butt. So enter the structure sensor. It is, I believe, you can get an app for like $299, $300, I think. And that includes the little the sensor, a bar that holds it onto your iPad, and then the cable that goes from your lightning cable into it. And then basically now you have a completely tetherless 3D scanner that you can walk around. And then when you're done, you basically email yourself the STL file that it scans, and then you can go from there and do all kinds of whiz bang things. So, and the quality is excellent. You got to go, it's way, I'm getting up like, I think like 25, 30 frames per second. And I'm using an iPad mini 3rd generation, I think. So, the horsepower's there. The scans turning out great. It was so good. In fact, I even was able to scan my wife and daughter and 3D print them on our printer bot metal. And it turned out really good. It was really impressive. So, if you're thinking about 3D printing, 3D scanning, especially if you're looking at like basically reconstructing something you already have, a physical object that you want to make a duplicate of. I've got a lot of projects I'm thinking about this year where, I'm going to take something I already have, scan it, and then I want to add like electronics inside of it. Like imagine like the model of a Starship Enterprise, and then got the inside, hollow it out, and put in like lights, LEDs, sounds, whatever. So that's why I went with this. Some other things, some other projects I got coming up. And there is, let me see here. So it's there's some other things they've demoed. There's a really big, I guess, update to the firmware that's coming out. I guess the company Occipital bought some other company. I forgot the name for the moment, but basically, I'm using it for doing a lot of scanning, 3D scanning, to be able to do manufacturing. There's also some use cases where they're basically doing like augmented reality, where it scans your room, and then it drops like animated characters in there, and you can interact with them, and they interact with the real world. So like if you've got a table and chairs, and after it scans your room, that little character, and they use a little rabbit, can bounce around. It can jump around onto your chair. It can jump onto your table. It knows what the real world stuff is, and then it just overlays and augment it, which is really cool. Not my use case, but still, it's pretty cool to think that all this stuff is rapidly coming into fruition. 2016, I think, is going to be a banner year for a lot of this 3D scanning, 3D printing technology, augmented reality, virtual reality kind of stuff. That's my rant. Some tools. So real quick, let me bring it up here. So if you are using it for like what I use it for, there's 3 pieces of software that I'm currently, let's see here, using. Let me bring those up. Meshmixer, which comes from Autodesk. Netfabb, which is predominantly there's a professional version, but the free version does what I kind of need it to do. And then there is Meshlab. which is completely open source. So if you're going to use the Occipital and you're going to get your STL file and you're going to scan it, recommend downloading a copy of Meshmixer from Autodesk, Meshlab, which I think the code is up on SourceForge, and the free version of Netfabb. Between these three pieces of software, I can take my 3D model and I can basically clean it up. Sometimes you're going to have little holes, little pockets. You want to make things watertight. These three tools kind of do everything that I needed to do, and it would be cool if there was just one. And probably if you got good at this, I'm still kind of an amateur, you probably could get away with just one of these tools. But I find that I need to use all three. Like for Netfabb, for cleaning up and removing parts I don't want, seems to work best. Meshmixer, if I wanted to like resurface the texture, seems to be better. And then basically Meshlab for correcting orientation, exporting to different formats. All three of these again run on Windows and OS 10. So I'm using them on the OS 10 version and they all work really good. So check those out if you're curious. If you've done 3D printing, the next step, once you've mastered, custom design yourself. So my recommendation is three things, right? First, go to like Thingiverse, just download 3D files, get your practice printing, learn how to use your printer. Once you've done that, you then use something like 123D Design or SketchUp to make your own 3D files, and then learn how to print those out. Then your third step would be doing 3D scans of real world stuff, and then cleaning those up and then printing those out. And then pretty much by then you'll have like you're the ninja of 3D scanning and 3D printing. I think that's that for that. That's for that. Something like that. Anyway, next whiz bang thing I'm excited about for 2016, the Glowforge. It is a laser printer. It is a very user friendly. It's kind of like, probably the Apple of 3D printers. And that's a double-edged sword. There's pros and cons, but it is very cool. It was a Kickstarter project last year. They are getting ready. I think they've had a little bit of delays here, but that's to be expected when you're doing something kind of brand new, and getting their first models out. But the nice thing is you can still pre-order them today, and you can get basically 40% off. And I'm going to say that, and I want to they've probably canceled that. So let me just check here real quick. Nope, still looks like they're 40% off if you pre-order now. So basically, you can get the Glowforge by itself for $2,400. If you wait until they launch, it's going to go up to $4,000. If you get the one that has the air filter included, it's $29.95. If you wait until they go for sale, it's going to be up to $5,000. So here's the cool thing about let me just explain a little bit real quick the difference and why I think the air filter one is worth it. Especially if you're in the maker kind of crowd, you're not a professional design house. So when you let's see if the video shows it. So as you cut or etch things with a laser printer, it makes really nasty smells and gases, and you've got to get rid of those smells. So there's the fan. Now, traditional laser printers, you would vent to the outside. So there either would be like a little, looks like a dryer vent. You vent that outside, and that gets rid of all the nasty smells and gases and whatnot. And you can do that. The Glowforge, the basic model, you have to either, as they showed some of the videos, make sure that it's near a window and that the vent can point out the window. And that works. Some things to consider is like if you're, obviously right now we're wintertime up here in the great white north that is Southern Maryland. but it's still cold out, and opening up a window probably isn't an option this time of year. Vice versa, in the summertime when it's real hot, probably not an option. It just open a window and let it vent out. The other option is to vent, build it, basically put a hole in the side of your house and vent it out that way. That's doable, but still a pain in the butt, depending on your skills and the desires of your significant other. So in my particular case, where we were going to use this as kind of like in the interior of the house, is where the little design lab is. That was going to be a pain in the butt. So the third option, getting the one with it has the filter built in. Basically, imagine it's like a stand that the scanner sits on top of, and you filter right into that. So this thing's basically a HEPA filter. And basically what that means is you can basically put this laser printer anywhere in the house. Doesn't have to be vented anywhere, and the filter just get to replace that every probably few months or whatever, depending on how often you print. So the cool thing about it, it will cut wood, it cuts plastics, it cuts leathers. It does not cut glass or metal. It will etch glass, it will etch metal. But the cool things about it, it's got 2 cameras inside. So orientation, being able to just put something in, not worry about the orientation, and just basically drop your design on there, orientate it in software. It's whiz bang, drop dead easy. You can use your iPad to do this as well. They will have an iPad app. The other cool thing is you can basically, and they'll show here in a second, their little video that runs in the background. You can draw on a piece of plastic or piece of wood by hand. You just take a marker, you draw on it. The Glowforge scans it, recognizes where you've drawn something, and basically will ask you where you want to etch and where you want to cut away. And so without having to do any 3D or 2D designs files, basically you don't have to know 2D design software. You can, if you're an artist, by hand draw out stuff, and the Glowforge will allow you to take that design and duplicate it. So that's one cool thing, is it'll save it and duplicate it. And then you can, again, you basically, it's one button, you design it, you send it to the printer, you go over to the printer, there's a one button, you press that, which is cool because that's a safety precaution, right? You don't want to just hit file, print, and then someone's got the printer open and their hands down there. So you do have to go over to the printer, physically press the OK button to print once you've got your material in there. So anyway, I'm a big fan, even though it's not out yet. I guess I'm a fanboy. I love the concept. I love the style is pretty simple. It seems very easy to use. But I guess we'll hold off final review until the actual units are delivered. But if you want to check it out, head over to glowforge.com. Like I said, I think they've kept saying they're gonna, I think they're gonna go from like 40% to like a 30% as they get closer to full scale manufacturing. Eventually, that discount's going to erode. So if you're thinking about it, if you're on the fence, just consider you're probably going to pay double what you can get it right now for as a kind of like a pre-release. Last thing. So I'm a proud owner of the Inventables XCarve, a CNC machine. They are coming out, and I had to check to see if their Kickstarter orders did actually ship. They say that their Kickstarter orders started shipping in December. I'm assuming that's right, but they still listed as a pre-order. So Carvey is basically an XCarve in a self-contained box that basically eliminates some of the, so with a CNC machine makes, basically when you're carving out wood or whatever, it makes a lot of dust. It gets everywhere. You got to have it vacuumed, to keep it clean. The Carvey is kind of like the Again, it's kind of like the Apple of a CNC machine. So yeah, you're paying a market. There's a premium, versus what you could either build your own, or there's other competitors on the market. But what they're going for is that, again, that ease of use. So there's that trade-off, right? Where if you want something that you have complete control over, means that you're going to spend a lot of time tinkering, getting it right, making it adjust it. Whereas when you buy these kind of, I want to say, just take it out of the box and it works, because it's not quite there yet. It's not that simple. But in that vein of, something that just basically you pull it out of the box, you learn it, you can make a little couple tweaks, but and especially the software. And this is where the open source argument kind of goes away, because I think a lot of I think Carvey, they use something called, they have their own custom thing called Easel. I think that's you can send it straight G code. The Glowforge is a little bit is closed source, as far as I understand. So there's this trade-off, right, where now we're talking about using proprietary systems, but if that enables you to make designs that then you in turn open source, in other words, even though you're not completely using open source tools, if your design and the design files that you use to make a product are then open sourced, what constant is that still a fair definition of open source? And I'm on the believer that yes, that just because tools aren't open source doesn't mean that the products you make with proprietary tools cannot be open source. That's a trade-off. That's a moral thing, I guess, depending on where you stand. But for me, the trade-off of having ease of use is so much worth it, because I'm the kind of I'm not a tool person. I wrote about this a long time ago. There's what I called was there's the product jocks, and something like the tool tinkerers. I can't remember what it was. Anyway, there's two types of people in general. There's people that love the tools. They always constantly they get into a hobby for the sake of basically collecting the tools. And then there's the people that only see tools as simply a means to an end. And I kind of guess gravitate towards that second one. I'll use any tool that lets me get an idea out of my head and into reality with as little pain as possible, even if that means I'm paying a little bit of a markup, and it's not totally maybe open source. So that's just me. That's not everybody. Anyway, so there's the three tools: the Occipital structure sensor, the Glowforge, the Carvey. Three tools that I'm really interested in 2016. But to get on for the demo project for today, let's cancel. Oh, well, maybe I don't. Let's go over here. So what is a bus pirate, first of all? So bus pirate is a little board, a little circuit board. It's basically the size of a matchbox that allows you to interface, sniff, send a lot of various different serial communication protocols. Two of the big ones being I2C or I2C, or I2C, I2C, and then SPI or SPI. So basically, it's just a way for chips on a board to communicate with each other. They pass information from chip to chip. The bus pirate basically takes the place of the microcontroller. So whatever the brains of a chip is, of a system, you substitute this for the brains, and now you can interact with all the sensor boards or the sensor chips or memory chips or whatever else directly. So you can, from the command lines, from a terminal, you can interface with chips, and you can also see how they respond to your commands. So we'll use an example in a minute. I'm going to use that digital analog converter. The way I do my work, I use this to send commands, and then I use a Saleae logic analyzer to record the commands or to watch what actually happens. To basically, it's an oscilloscope that focuses on digital communications, and usually they have an analyzer that can decode the protocol. So in our case, we're going to focus on I2C or I squared C, and the Saleae lets us actually see the signal bounce around the chips. So the bus pirate, let's go. So those are the two tools we're going to use. Let's go ahead and switch on over now to my little setup here. Let me switch cameras. All right, let's get rid of this thing down here too. That's getting in the way. Let's turn that off. All right. So down here, there's a little bus pirate. Our chip of interest is underneath here. I will say, so using these logic analyzers and whatnot, there's a lot of probes. There's a lot of probes. It's a lot of cable. It is a rat's nest nightmare to do this kind of stuff. That's why, like the little pogo, building a little custom pogo pin debug or troubleshooting device or test bench or test stand or whatever you want to call it is so invaluable. Because there's a lot, it's a lot of pins and they're very small and it's all together. So anyway, the bus pirate on one end is a USB, goes to your computer. The other end has got the ribbon cable that has all the various probes. You have to know which probe goes to which pin. It's all very well documented. And then the other set of pins of the probes on this side go to our logic analyzer. And then I've got my multimeter here just to see. We're going to basically digital to analog converter. We're going to basically tell it to send out various voltage levels. So anywhere from 0 volts up to 5 volts. And to do that, we're going to use, so that's the hardware setup. Let me go ahead and switch back over to the screen. Screen 1. So let's take this. Let's minimize this. I'm using an app called CoolTerm. It is a terminal window. So back, Windows Putty is very popular. It's way, when we would telnet in or SSH into systems. Well, in this case, we're using it to talk to our bus pirate and tell it to do various things. And you do that. Basically, it's serial driven, or a command line driven. Real quick, in case anyone downloads CoolTerm and is using it, let me just show you some of the settings that I had to tweak to get it to work. So make sure you obviously check to make sure you're connected to your bus pirate. The baud rate 115,200, so 115,200 bits per second. Each packet's 8 data bits wide. We're doing no parity. 1 stop bit. Turn off all the flow control. The initial line states I don't think makes a difference. Let's see here. Did I change anything on the screen? So the one thing to note is handle BS, backspace, and delete characters. If you don't tab this and you go to delete, you're basically, you make a mistake typing something, you won't be able to delete. So you got to check that box on the terminal. I think on receive and transmit, I didn't change anything else. I feel like there's something else I did change. Maybe not. Oh, yeah. Enter key emulation. It's defaults to I guess carriage return and line feed. Set that to just a carriage return. And once you've done that, go ahead and hit connect and watch this not work for me. hit enter on your keyboard once, and boom, you should see something that says high Z, high impedance. That's the default state. So in our case, we're going to go ahead and type in little m. That brings up the menu. We want to go into I2C mode, I squared C, so I type number 4. And again, this all depends. I guess this would vary in the firmware. So if you're using a newer firmware of the Bus Pirate, this might change. So check the user guide. But I'm using a Bus Pirate 3.6. It came out. I bought it about a year ago, and I don't think I've ever updated the firmware. So whatever came with it about a year and a half ago is what I'm using. I tend to go with the 100 kilohertz as for my speed. I go ahead and hit ready. Now I'm in I2C mode. So now what I can do, type big W. That'll turn the power supply on. And if I was showing you the board, the little red LED would light up saying I'm pumping 5 volts out. I also want to turn on the pull-up resistors. So got that going for me. And then if I'm really lucky, I type parentheses, open parentheses, 1, close parentheses. This is going to let the Bus Pirate basically scan for any I2C devices it sees connected to it. And of course, I've got something fouled up because it said it doesn't see anything. And that is probably because, let's see here. I've got the serial data line popped off my let's try to connect that. All right, let's try this one more time now. There we go. Okay. Make sure again, there's a lot of pins. There's a lot of little probes. Make sure that they are all connected, else you'll get this problem. So here we go. It sees basically here is our MC4725. We have the write register and we have the read register. So so what I want to do is basically tell I'm going to write to it and I'm going to say basically go low, go turn off the thing. So we're going to open bracket 0x Charlie 0 C0 0x 00 0 x 00. Again, every chip has a data sheet. Data sheets will explain how you can interact with the read and write register. So if I go ahead and enter, there it is. It's transmitted these bits. So the Bus Pirate sent this over the I2C bus to the MCP4725 digital analog converter. And if you're looking at my multimeter, you would have noticed it just went to 0 volts. So let me go ahead and let me stop doing this. There we go. Switch back to the camera. Oh, there we are. We're already back. So if you notice up here, that's let's do the opposite now. Let's do 0xC0. Let's tell it to go to 5 volts. So 0x0f space 0xff. So now I'm say basically go full tilt. There we go, 4.9 volts, so 5 volts. And now just for grins and giggles, I'm going to go back to 0x00, 0x00, basically turn it off again. I'm going to get ready to hit enter. We should watch this. It'll go to 0 volts. There we go, 0 volts. So that is basically showing how the Bus Pirate, how you can use the Bus Pirate to send commands to a chip, and then you can, with different tools, basically record, probe, how those commands cause the chip to do various things. So in this case, digital to analog converter is taking that digital string and making an analog voltage based on the 0x000x00 is equates to 0x0f 0xff. Basically all ones basically says go to max voltage. In this case, we're hooked up to 5 volts. So that is controlling, that is sending commands out. That's what the bus pirate does best. Let me switch back over now to screen 1. Let's present this to everybody. So now let's bring up Saleae, logic analyzer. So whereas the bus pirate is good at sending commands to a chip, sometimes we want to spy on the bus. I have to be careful how to say that because SPI and spy. Sometimes I want to monitor the bus. In this case, it's an I2C bus. And I want to see what's happening between chips. So you can imagine for a moment, say you didn't have a bus pirate and you had a proprietary product, you opened it up, and you were tinkering inside it. You wanted to see what are the commands that the microcontroller is sending to a chip and vice versa. What is basically, how are they speaking back and forth? How do they work? Any logic analyzer does that. Again, I just prefer the ease of use, the pretty screens of the fact that the Saleae works with my MacBook. All right. So basically what you would do is you would hook up, say there was 8 pins coming off of a chip. You would just put your probes on every pin because one's going to be voltage, one's going to be ground. And in the case of I2C, there's going to be the data line and there's going to be the clock line. And you don't need to know which one is which. You just put your probes on there, and then we'll let the tool figure that out for us. In my case, since I've done a little bit of homework to save time, I know that either the data line or the clock line is on channel 0. Just ways I put the probes on there. Obviously, if you were doing real tinkering, you would just go with one channel at a time. I would set the trigger because the way I2C has a pull-up resistor. So the line, when it's not being used, is going to be whatever VCC is, in this case 5 volts. It's when it drops to 0, that's when basically all the magic is happening. That's when the communication occurs. So you're looking for a falling edge. So when channel 0, and I think 0 is the clock. I think it's the clock. So when the clock line goes to 0, that means I'm getting ready to start a communications. Then start recording, because otherwise I don't really care. I want to wait until there's actually something useful to watch. So I'm going to enable a trigger that looks for a falling edge. If you were looking at a communication protocol that was 0 volts or grounds normally, and it went up to a VCC, you would probably want to put on a rising edge trigger. But in our case, we're using a falling edge. So I'm going to go ahead and also bring up, boom, 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 boom. Where did it go? There's CoolTerm. So I'm going to put this guy down here. I'm going to shrink it up a little bit. And I'm going to basically pre-populate 0xC0, 0x0f, 0xff. All right. So I'm getting ready to run that command, but first I'm going to go back up here to my logic analyzer. I'm going to do 1,000,000 samples at 4 megahertz. Again, wait, and then by the fact that I put the falling edge trigger, wait until I trigger. So go ahead. I'm going to hit start here. Bring this guy up. Hit enter. Boom. There is our data. So channel 1, I'm going to go ahead and hide that because there's nothing there. I'm going to hide this one to prevent just confusion. So now here's our area of interest. So remember, down here we wrote 0x-C0, 0x-0f, 0x-ff. So the 0x just means we're sending this, assume that this is hexadecimal code. That's all the 0x means. You can ignore that. C0, so C is equivalent to the digital, or base 10, the number 12. So that would be 1, 1, 10, 11, 12, A, B, C. So it would be 1, 1, 0, 0, and then 4 zeros. And it'd be the opposite here. So then it would be 4 zeros, 1, 1, 1, 4 ones, and then 8 ones on the data line. So it should not be a surprise that there's it looks like there's kind of like 3 groups of packets, or 3 groups of bits that are sent. That this does in fact correspond to the fact that we sent C0, 0F, FF. And if you zoom in, or actually before you zoom in too much, go over to the analyzers and tell it to run I2C and say channel 0 is, so the data line is channel 2, the clock line is channel 0. Save. I go ahead and tell it to rename. And so now, when we did it do that right? Well, let's try it one more time. I2C. The data line. Oh wait, the data line is channel 2. The clock was channel 0. Rename it. There we go. Okay. So now when you zoom in, you notice it has W, not 192, 15, 255. So those are the base 10. That's the decimal equivalent of, so again, we sent 0, we sent a C0 in hexadecimal. So that would be 1, 1, 0, 0, 0, 0, 0, 0, 0. So 2 ones followed by 6 zeros. That would be 64 plus 128, which equals 192. So 192 in base 10 is C0 in hex. 0F, 4 zeros followed by 4 ones. Well, 8 plus 4 plus 2 plus 1 is 15. The 4 leading zeros in front of it, 15. So 0F in hex is 15 in base 10. And then the last thing we sent was 8 ones. 8 ones is 255. And so there we've basically captured, and then I'll zoom in a little bit. We'll focus on 15. Where when we sent base, 0x0f. So on the rising edge of each clocks, we went, basically we sequentially took in the data. So on the first rising pulse, 0. Second pulse, 0. Third pulse, we took in 0. Fourth pulse, 0. On the fifth data pulse, now data line was high, so that's a 1. The 6th pulse was also high, 1. 7th pulse was high, 1. The 8th pulse, so we know it's 8 bits. So there's the 8 bits, and then this down over here, this last bit is how we know it's an acknowledgement. It's saying this is not part of the data. This is the protocol saying I'm done with this this packet of data. So we focus on these first 8 clock transitions, and that's how we read. So 0 0 0 0 1 1 1 1 is 0f. 0f in hex, or is hexadecimal. In decimal, 0f is 15 plus the acknowledgement. And that's how you can kind of figure out what type of data is being passed back and forth. Even if you don't know what it is, you can at least start figuring out how, how's the system built? What is the address? Because the first thing is always the address. And then it's the data, and then you could figure out how the data is by you guys monitoring the stimuli. In our case, we're monitoring the analog voltage output pin. And if we played around long enough, we would probably eventually realize that this is a digital to analog converter. This is the address I write to, and then if I put in 0000, I get 0 volts out. And if I put the max value, which is 15 or 0f, FF, I would get the max voltage out, which is 5 volts. And that's in a nutshell. That's the logic analyzer part, looking at how to read the signal, and the bus pirate using via the CoolTerm terminals app, how to play with the bus pirate. Hangouts basically is crashing every couple of minutes, and I think most of what I wanted to record got through. But I guess I'll have to take a look afterwards and see. Anyway, so that's the bus pirate. That's the Saleae logic analyzer. There are lots of solutions out there for both. I just prefer those two because, again, cost, performance, they're good enough for what I need to do for most of my jobs. The Saleae, I have an older one that's only a logic analyzer. The newer ones have analog as well. So it's kind of thinking of like a mini little oscilloscope. I still, for an oscilloscope, I prefer to have buttons and knobs, because I've never found one where the software defined oscilloscopes. I've just never found one that they've made that intuitive leap for what a knob and a button does on a digital scope. Hasn't quite translated well into purely a software defined oscilloscope. So that's just my personal. Anyway, so with that, again, I apologize. We are in the midst of working on a bunch of projects. The lab's getting redone. We're ripping out old supplies. We're getting some new stuff. And it's just a mess, and it's nuts, and it's crazy. And again, I apologize and appreciate your patience and understanding, since it's been almost 2 months since our last episode. So with that, we're going to try to do a Steam Power podcast tomorrow to kind of catch back up. But obviously no promises, because crap happens, and this isn't a full-time gig. So anyway, trying to think if there's anything else. So we'll do head over to gearsofresistance.com. There'll be links to everything we talked about today. And more importantly, links to places where you can comment back to us, and what do you like, what do you don't like. A podcast just talking about open source hardware isn't kind of fun. I think I'm going to go back and try to rethink about doing this as more of a how-to tutorial podcast, and less just talking and ranting, and then save that for Steam Power podcast when Lisa joins me. So anyway, I think that's what I'm thinking about. I'm not sure what I'm thinking about totally. That's what I think I'm thinking about. And before I guess Hangouts crashes again on me, I'm going to leave it there. So again, thank you all very much for listening. Head over to gearsofresistance.com. Hit links to everything else we do. audibletrial.com/steampowerpodcast to sign up for a free 30-day trial of Audible and get your audiobook listening on. So that with that, until next time, thank you all very much, very, very, very much for listening or watching. And until next time, keep it steamy, stay quirky. And I thought I had something else, but I don't remember anymore. We'll see you next time. Bye.